basic web services, okay? Because for our project, we ask every team to build a web application or web service application. Um, we highlight web service. We want you to know that this is not a website, okay? When we talk about a website, most of the time it's a static page, right? So you go to a very simple landing page, you talk about the company, talk about the product. That's called a website. When we talk about web service, that means that web application, that web UI or website looks like a website, but it can does some kind of specialized, personalized service for you. Google is a good example. You type different keyword, you got a different answer. Or you go to log into Bronco Direct, right? So you log in with your account, you find out your information, your records. Okay, that's a web service. Okay, so very straightforward. So it's a web-based UI allows you to interact with some kind of service in their background so that you can achieve something, fetching information, store things, social media, chat, anything. Okay, so we want everyone to build a web service application or web app. Okay, you can think about that way. All right. So today and Thursday, I'll show some quick demos on what are the things you need to build, what are the major components you need to write to make a web service application. Some of you have done this one. This one isn't going to be too difficult for you. From what I learned before, most of you have not built a web service application before. Okay, because obviously this is not a scope of our CS curriculums. Most department won't teach you web service development, but it's a very practical subject. You will need to learn quite a lot of things in the beginning. You have to understand the back end, front end. You probably need to all of a sudden learn a lot of new languages you never used before, but it's not too bad. Okay, so that's why you have a team. You can always split the work. Everyone focus on one component, and yeah, there will be some learning process. I'll spend maybe 2, 3 lessons, go through some of the most important ones. But since this is not a web service application course, I can't teach too much. But I want to show the simplest example. I also want to do that really fast so that it makes you less intimidated. You don't really feel this is tons of things to do. It's actually not too bad. Especially today with all the libraries and tools getting more advanced, with the help with AI, you can build these things really quickly. All right. So I want to just dive into the demos. In old days, I often show some lot of slides to give you all these different concepts. I think that's not very necessary. Let's just dive into the demo. I think that will be the best way to demonstrate what is a web service application, what you're supposed to build. I'm going to use this example. This example coming from our old team. I think it's the very first team. Actually, let me show you. In this website, says for the projects. This is where we record all the historical software engineering courses. I think this is coming from the very first class back in 2015. Okay, exactly, 10 years ago. And then they have this project called $5 lunch. I really like it at that time. So let me find which team did that. Yeah, this one. See, this time the course was called 480, okay, because we were in a quarter system. And once we changed the semester system since 2018, 19, and then the course number changed. Okay, those are four guys. I still remember some of them, but I haven't checked where they work, but they're pretty, probably doing pretty well somewhere. Okay. So this was the thing they launched, but obviously the link won't work. Okay, but they got a domain name at that time. What they're trying to do at that time was that to solve a problem very simple. Okay, it's almost lunchtime and you want to get your lunch options, and then we want to go with a budget. Okay, so tell me $5, what can I get on campus? Okay, obviously today it's 10 years later, $5 really can't give anything. But I think 10 years ago there were quite a lot of good options. Okay, so you type your cost, $5, $6, and then it just gave you all the options from campus. And they did put some efforts to collect all the different pricing items, the menus, and then they actually do a lot of stuff here. Okay, very simple tool. That's called a web service. So you input different things, you get different answers. So this one is very simple, but over the years, our project getting more and more and more complicated. Okay, so from these years, I think I'm gonna put some requirements on the complexity functionality. I haven't figured out how do I require that, but because now we have AI, so you're supposed to do a lot better than before. Okay, so anyway, but I'm gonna use this example to demonstrate what you need to build and how does every component work together. Okay, so you think about the problem and this is a solution. Very straightforward. It's very simple UI. You go there, there's a logo, $5 lunch or whatever you call it. And then you input the box here, types the budget, it's just a number. And then you click on the button to search and it shows you all the food items that's below that pricing point. Very simple. Okay, just a very simple search tool. All right. But this is the front end. Okay. What do you see from the browser? All the web UI component, the layout, the way you interact with, that's the front end. But since it's a web service application, it works also with a backend because where do we get the data? Okay, where do we do the search? And although this search logic is very simple, but still sometimes you have to build more complicated business logic. So if you look the whole picture, um, most of the time the web application follows something called a three-tier architecture. Okay. So when we say three-tier, that means they have a front end. That's what you see from the browser, all the UI stuff. And then there's a backend. But backend, we normally still split them. There is one thing called a database. Okay. And then you also have a specific server program that sits in between the database and the front end. So the three component here is called as three tiers. So normally people think this one at the bottom tier, this one in the middle tier, and then the front end is in the top tier. Okay. But you don't see the three tiers in very often today. Most people talk about front end, back end, but you should know for the back end, normally there are two things going on. Okay. So because when you are trying to deal with a large number of data, you do a lot of queries, you often have to use a database, a professional database to store those. Okay. I assume most of you took the database courses already, right? Yes. Okay. So maybe I know that's not required, but that could be a good course to know. Okay, but because database still used and a lot of it, fundamental concept is pretty critical. So you need to have a database, and then for the website, very rarely your application will directly talk to the database. Although you can do that, but that's a very bad practice because should be very well protected. And so that's why in general you have this middle tier, like some kind of a backend program that connects to the database and do all this logic queries, computation, other things you need. And then your friend then normally talk to your server program instead of talking to the database directly. Also, your data is actually from here. Because sometimes you store the data, but then when you send it to the friend, then you still want to do some manipulation, some processing. That's the good alternative for you to handle those in the server program. Okay, so it's just three components. So every single project you guys are going to work on this semester must have these three components. Okay, you should have a database, you should have a backend server, you also should have front end. Now, front end, most people know it. You build a web front end. The most important languages are HTML. Okay, everything you show from the browser is shown and rendered in HTML. And then to make the style, make the things that looks nicer, you use something called a CSS, right? To control all the layout, the color stuff. And then, but if you want some more like a dynamic interactive web interface, you normally need JavaScript. And also you use JavaScript to talk to the backend servers. So for the front end, you do need to touch at least these three languages. Okay. And very often we heard about other like a modern front-end frameworks. The most popular one today, like React.js. And there is a thing called AngularJS. I don't know Angular is still popular, but there is another one called Vue.js. And these are normally the three major front-end frameworks. And recent years, I heard about Next.js. That sounds really even more popular, but it's still based on React.js. But a lot of these things going on, but they are all kind of a front-end frameworks you can use to build the front-end UIs. Okay, database, most of you probably heard about some open source database like MySQL. Um, Microsoft has a commercial one called a SQL Server. And the biggest database company is Oracle. Their database is super, super expensive. And then you also heard about some other free ones like PostgreSQL. But those are the traditional databases. But they did since 5, 10 years ago, people started to switch to use something called NoSQL. Okay, that you might heard about MongoDB, you heard about Cassandra, you might heard about some of the new ones. Other names I can't all remember. And then recent years, I know there's even more advanced things like a graph. database, GraphQL, things like that. But it's all different type of a database that support different kind of feature performance. Okay, so you will need to choose one of the options for a database. Okay, for the server program, there are many options you can do. You can write in any of the major languages. Okay, 10, 15 years ago, Java was dominating this field. The reason Java was so popular was because Java was normally the number one choice for writing the backend programs. Okay. Most of the time you learn Java, you didn't know to use Java to write a web service or service. But in all the major companies, except Microsoft, because they use their own .NET framework, Google, Amazon, 90% of their servers are written in Java. The years they've been changing, but if you look at their main backend code, most of them are Java. So that's why Java has been very popular. Until recent years, I think a lot of the new languages, Python, other like a language like a Go, or those start to kind of become more efficient, and then Java started losing some of the popularity. Okay, but you can do with Java, you can do Python, you can do Node.js. You heard about using the JavaScript. Some of the new ones that I mentioned, Go is very popular, a language from Google. Also good for writing the backend programs. And you can do, if you want, you can still do C# using the .NET framework. And there's something called Ruby on Rails. You might have heard about PHP, all of those. Those are major things you can do for the backend service. Okay, so I just want to summarize all the terms you've been hearing every day, what they are, what are they used for. Okay, but it's your choices to 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 decide. Okay, which one to use. It doesn't matter. But I do suggest you go more with some of the trending ones. Okay, don't be afraid that this is something you haven't done before. Most of this isn't too difficult to learn. The newer the language is, the easier it is to use. Always the case, more efficient. You write less, you do more things. Okay, so don't be afraid of picking the new and trending languages or frameworks. Okay, I do suggest don't touch the older ones. .NET, pretty much nobody's using that. The Microsoft framework. If even you do that, spend some time learning, it's not very useful. Java is still okay, but for database, same thing. Maybe instead of using the traditional relational database, maybe stick with some of the newer like NoSQL databases, just because that's where industry is heading to. Okay. All right, so this part you can still do a lot of research. Okay, you guys can discuss, and some of you probably know certain things better, and you guys can make a agreement on what one to use. But anything I think you can find a pretty much a lot of resources. Okay, so what I want to do is I want to use the simplest way to build a quick demonstration on this service. Okay, it shouldn't take too much time. I think we only need like 30 minutes to build it. Okay, so normally you start from the backend. Okay, because you have to set up all the data foundation first. That way, when you build a front end, at least you can start to interact with the backend a little bit. Okay, so normally we start from the backend. And when you start from the backend, you got to first think about where is your data, where do you store your data, and what the data do you have, right? So start from the database. Now, today I'm not going to bring the professional database, but I want to just use something really simple to demonstrate everything. Okay, so I will use a simple like a file, like a database. I'll do this one called budget lunch. All right. So dealing with the data first. So I'm gonna put everything back in Python. Okay. So next time we can show you the database. Okay. So this time I'm gonna use my just use a local like variable to store this. Okay. So we'll call it LunchDB. Okay. I'm gonna create a list. All right. So this list, since there are a lot of food items, okay, I'm gonna have the name. All right. So I don't know why it's popping up as a Korean. But do something simple. All right. And then we do the price. If this is $6. And yeah, I'll just start from the two. Okay, just to make it simple. In the same way, we can, yeah, looks like they can start to get us more things. Um, Yeah, we're gonna take those. Okay. By the way, if you haven't seen this one, this tool is called Cursor. I didn't mention that in week one. They do a lot of this code compilation. We actually saw this one from the previous course. It does something really crazy. Okay, so it can pretty much figure out what trying to do. Even some of the data and examples you're trying to use, they can find the real data for you. Okay, but pretty simple. Now here, I just use a little list in Python that stores some kind of dictionary here to store the data. This consider that as your database. Okay. Now what you want to do is that I want to replace some of this one. Okay. What you want to do now is to write a program that you can search based on certain kind of input budget and then return all the items you want. Right. Um, Building that kind of a search in Python isn't too difficult. Okay. I'm gonna do a function. Okay. Search food with ice. All right. And well, it looks like they got as a code, okay. But I'm gonna still write I can't write that whole the single line. It's kind of a for loop, okay. I'll just do the simple ones. So I'm gonna create a result as a list, okay. I'm gonna iterate every single food item, right? And then if anyway, so since they wrote it, okay, I'm gonna do this. So we got a food, look at the price. If it's less than the price we provided, and then we're gonna add that one into the list, and then we return it. Okay, so that's a very simple function. And see, they know we're gonna try to test it. So we're gonna go with it. Okay, we're gonna test this one. I'm gonna test that with a $10 meal first. Let me run this. All right, as you can see here. Yeah, I don't quite like this output here. Okay, so you can see there's one, two, three, four items displayed because they're all below $10, right? So if I do $5, I run this again, and only soda and coffee are here. Yes, right. So only two items. So pretty straightforward. Okay, so this one everyone can write it very quickly. So this one looks very simple, but don't forget, this is our initial version of our backend. Okay, you got a database, I use the variables, you can use the files, and then of course you can later on switch to the real database. And then you have a little Python program that does all the logic. Okay, so they handles how do you search. Now this is a very simple case, but if you have more complicated cases, you basically write more code. All right, so that's a very good first step. Okay, however, guys, this is not a server program. Okay, this is only a standalone Python program. It does the logic you want, but it's not a server. Because if you think about a server, some of the important thing to make a server. First of all, this server should be always running, right? Whenever I go to Google, I search, I type, even it's early morning, it should be giving me responses. So this one shouldn't be stopped. Okay, so you must make sure the program always runs. But now we only just click on the button and run it once. That's not what we want. All right. But at the same time, the bigger problem is that this time, this search you see the logic working, but how could people actually call this one? Okay. Right now, the only way is you get this code, you download the Python code, you open that in IDE, you know how to run it, and then you type the parameter to run it. That's fine. But for most users, they don't know anything about programming, they don't have access to the code. They can't run this one. Okay. You must make sure this program is very accessible. Okay. Anyone can easily visit and run this code to get that search feature. Okay, so that's what the server program is trying to handle. All right. So let me ask you this one. How do I make sure this program always runs? Instead of I just click on this once, okay, can you make it something keep running? How do you make a program keep running?
Send to a cloud.
Send to a cloud. Yeah. You mean run this code in the cloud? Yeah, that's a big picture, but just from a coding point of view, like for the program, right now I click on the button, run it, it's that. How can I make sure it's keep going? Loop, right? Well, yeah, I do a for like a while true loop, right? Something like this. Okay. Well, at least this one like keep going. Okay. But yeah, it's getting closer. At least it's a way to make sure this one always runs. But obviously, you can add some other things, maybe wait. You can take a user input, or those. You can do a prompt to say, okay, what's the next, and then you can quit something like this. Okay, yeah, you can use a loop. But is this really the best way or efficient way? Okay. So you all know that when you run with this infinite loop, right? So that you keep CPU, busy all the time. It's a lot of res waste on the resources. Okay. Obviously, that's not a great, right way to do. And then the bigger problem with this one also is that um, most of the services you need to allow multiple users to access at the same time. For example, Google, we all can go there to search to get the result at the same time. You can run things in parallel. But when you put stuff into a loop like this, you're forcing things to go one by one. Each time it only handle one request, one response. Okay. So for server programs, you really can't use this kind of a loop to handle things. Okay. It's too much width. It doesn't allow in parallel computation. Let me just ask you a technical question. No, we don't have to write a code. How can you make sure a program that runs and also allows a really good parallel handling, like calling the functions multiple times in parallel? What are the techniques you guys use to enable that?
Async.
Async. Async is the effect you see, but what from the programming point of view, what's the language feature to support that? Yeah, you do a keyword async, some of those, but what is a programming technique you support async? I'm sorry? Yes, thread, multi-threads, right? How many of you have done multi-threading programming in Java or Python? Couples. Oh, very good. Where did you guys do that?
Parallel process.
Oh, there's parallel class. Okay. Okay, project use that one. Very good, very good. Okay, so since you guys learn Java, right? So in Java, you do a class, new thread, you can do rendezvous interface. Python, I don't do too much. I can't remember how to do that one. Okay, but in most of the major programming languages, you can do multi-threading programming, which means that you can run things in parallel if you put them under different functions and then run them into different thread. Depending on the capacity of your computer CPU, you can generate as many threads you can. So theoretically, they can be running in parallel. So that kind of programming model is really good for servers. That's exactly what all these major companies are doing. So in their server, in their machine, they have thousands, hundreds of thousands of threads going on. So whenever people are visiting, sending requests, every thread is going to handle the request. Because that's the practical way. And then there's a better way to manage all the different threads. It's called a threading pool. So you create a pool, and based on the needs, you create new threads, and you let this pool keep going. So that's the foundation for building a server program. Obviously, I can't demonstrate this one right here. Okay, it's too complicated. But multi-threading is the major technique to support this type of architecture. Okay, so if you guys want to one day dive into certain languages, um, you want to become more professional, more senior, you must master the multi-threading programming. Okay. I'm sure a lot of you are pretty comfortable with Java, with Python. You guys probably code that for many years. Some of you probably did that in high school, middle school. You're probably very confident about your Java skill, Python skill. Okay. Remember one thing, you never want to call yourself a Java or Python expert until you have done enough multi-threading programming. Okay, that's a different story. Okay, you might know the language very well, you might do the lead code very well. Oh, that's great. Okay, but in practice, the most complicated programming often happens in the multi-threading scenarios. Okay, in Java, there is a book if you're interested. Okay, it should be this one. So this book you can mark it. This book only talk about the multi-threading. It doesn't talk anything about basic Java. Okay, this book not too it's okay with hundreds of pages. This is the one of the most difficult program book I ever read. Okay, it doesn't it's very concise. Okay, they talk things very clearly. Um, but then you really have to go through and try those examples back and forth in order to fully understand. Sometimes you feel you understand it, but then you see some other things, still a little bit confused. Okay. I found this book in a lot of the engineers' shelves back when I was in Amazon. So in Amazon, they have a little small cubic, you have a little shelf. A lot of developers at that time they put a lot of books there. Now today's I don't think people still use the printed books. So this book, you can see that everywhere. Okay. It's a very good book, just talking about Java multi-threading. They talk about how the log works, synchronization, control the resources. Very difficult. Part of the reason this is difficult because when you run things without parallel, without multi-threading, everything is sequential, it's serialized. So you can predict what's going to happen next, right? All you need to do is figure the logic. But when you run things in parallel, the things are uncertain. You can't predict or you can't assume the order. You just have to think about all the possibilities. That's where things getting very tricky. Some of the very senior developers shared with me back in Amazon, most of the time in when there are major technical issues in the Amazon server, some of the things down or crash or slow. If you go back to see the root cause, most of the time related with threading. Okay, because when you write a program with multi-threading, it all works fine locally, but the moment you deployed it, okay, a lot of very special the edge cases happens, and it may not break your server at once, but once you accumulate more and more threads, more and more requests, it is all the memory, all the resources, and then your server start kind of stuck there, and all of eventually the server crashes, and you start to see the request getting slow and slow. So if you go back to dig into the root cause, a lot of time the issue will relate with the multi-threading. Okay, most of the time you gotta be like seniors or they call it principal engineers in order to handle those very well. That's what I learned. Okay, so anyway, so if you want to dig into programming, you want to really become a little bit more expert, this will be a good topic to touch. Okay, same for other languages. But anyway, here I just want to show you that if you want to use the multi-threading to build all of this, it's not that easy. Okay, you can probably write a prototype, but whether it's efficient or not, it's not really that easy. Okay, so but for server program, you do need to have this one. Okay. Also, I did mention raise another question that besides the multi-threading or concurrency, when you are doing this one at the server, you need to make sure this is accessible easily. And obviously, we don't want to share the code to everyone to run the Python code to do this one. We want people to very quickly um, make a call and to use the function, even remotely. Right now, I'm the only one who can run the code locally. How do I make sure everyone, you guys can also run this code remotely? Now, clearly the answer is you need internet. Okay, somehow if I can pass the code to you, you can call it remotely in your computer and then get the answer. That would be the ideal case. Okay, that's exactly what a server program will do. You never need to run and load all the code to your machine like Google's code. All you need to do is make a call to them, and then they handle on their side, they give you the response to you. So they do everything through internet. And if you learn enough about networking, so they need some kind of protocol to do this. Okay, what are some of the typical protocols that we use to do this type of communication?
Rest.
Which one?
Rest.
REST. REST is not a network protocol. REST is a web service framework. Like you're sending, we call Google, right? We go there, type a keyword, hit a button. You're sending a request to Google server, and then they give a response, right? So you use all the internet and Wi-Fi stuff to communicate. But what are the protocols from the network point of view being used here?
TCP.
TCP, what else? Yeah, HTTP. Okay, I'm sorry. UDP. Yeah, so TCP, UDP, that's the lower layers. Okay, but then from the application layer, like you go to the website, you see all the content, that's through something called HTTP. Okay, but HTTP is built on top of the TCP, UDP. They have this 7-layer network. Okay, but once again, some of you, I don't know how many of you standard network courses. Okay, you don't have to take those today. In the past, that's normally the required courses. But now I think if you know the basic concept, know how to build stuff, that's fine. You don't have to know all the details. Okay, but HTTP, that's the protocol. Okay, so anytime you go to a website, for example, you go to here. Okay, if you open uh this one, if you open let's see, where is the networking? This one. All right, so I refresh. You see, they send all these requests to try to load different things. Okay, images, files, JavaScript, all the file stuff coming from a server, from our CPP server. So there are a lot of requests going on. Request response, request response. So your browser sending all the requests, you got all the responses, and you render them in the browser. So the communication is called that request and response. And as you do the communication, you do need follow some rules. Okay, that's how you use all the network, all the bandwidths. All right, so that protocol is called HTTP. So HTTP basically specifies how the people use the network to do this communication. And if you want to find out that specific specification, and you can look at it here. I think this is a complete version of it, but I want to show you one thing here that's a little bit like a more complete. Maybe this one. Yeah, this one. So this, as you can see, just from the documentation, you can see this is a initial, like a most official, like a documentation on how HTTP works. This is a long documentation, like it specifies a lot of different things as you interact with the internet. How do you send the data? What's the format? What's the headers? What are the attributes? What does it mean? This is a long documentation for the whole HTTP. Okay, so most of the server we use today, when you communicate, you send HTTP. Obviously, the browser handles that. But on the server side, what your program need to do is to be able to receive all these requests coming from the internet and be able to understand what the requests are, be able to parse all the data, all the content, and then you do the right thing. And then you also need to know how to send it back to the requester. Okay, what's the format to use? How to interact with the networking stuff. Okay, see that part, if you want to build that into your server program, it's really complicated. Okay, there's no way you can do that. I can just tell you that way. Not a single individual can easily write a program, can implement everything from HTTP, understand the networking, listen to the networking parser, and then send it in the back, and adding the multi-threading everything. See, my point here is that I want you to know, building this logic is super easy. But turning this little standalone Python program into a real server program, that's going to require quite a lot of work. Okay, multi-threading, threading pool, HTTP, interacting with networking stuff. That's too many things to write. Okay, you can't finish that. All right. So server program is not easy. Okay, but fortunately, we do not have to write those today, because the server program follows a very specific pattern. Okay, every single server program needed the same thing: threading pool, request, response, understanding HTTP, interacting with the networking. And people realized, well, why don't we just build some kind of a code base that does everything for people and give this code base to people so that they can build the things they want on top of it. Okay, so in other words, there are people, they build or wrote this kind of frameworks for us. Okay, when you think about a framework, okay, they have a code base, those part that we can reuse, and then we write things on top of it, and for the specific function that we want. All right, so that kind of frameworks is called web frameworks or web application framework, whatever you call it. Okay, when you listen to those terms, now you need to understand. So the purpose of having those is to help you to deal with the most complicated part that most of us don't know how to write, because this part of the program is really hard to write. Okay, just look at the protocols. There's so many things you have to implement. Okay, so some of the major ones, I know you heard about Java. There's something called Java Spring. How many of you have used this one or heard about this one? Yeah, very good. So this is the one that most of the big companies are using. Okay, you all know Java, but Java Spring, Spring is basically a bunch of packages and libraries that they're a code framework that if you import Java Spring into your Java code, then you can write a server program very easily. Okay, Python has something called Django. right? Again, they use Python, but the Django is a framework that allows you to build servers from Python. You heard about Node.js? It's written in JavaScript, but Node.js, I'm sorry, not Node.js, Express. Okay, the Express is a library written in Node.js or JavaScript that allows you to do all this kind of web service stuff. Okay, I mentioned before .NET, Microsoft .NET. When I was in college, this one was very popular, but not anymore. They use C Sharp, and then they also provide you a lot of this kind of frameworks, as you can see, .NET frameworks. Ruby on Rails. Okay, Ruby is a programming language, pretty hard to use, but the on Rails is kind of a bunch of libraries and framework that allows you to build web application. 10 years ago, this one was very popular, but I don't think it's that popular anymore. Okay, so you see all these different terms. Okay, they are called frameworks. They help you to build your web application. Okay, today I'm going to demonstrate one of the easiest one of my favorite because it's so easy. Okay, you literally just write 3, 4 lines of code, you can get this whole thing done. Okay, what I like to use is something called a Python Flask. Okay, Flask, the Django is a large scale, more professional, more production level kind of a service or framework, but Flask is really lightweight, simple. I like simple stuff. A lot of times, simple stuff is enough. Okay, so. What I'm trying to show you here is I'm going to show you how you can use Python Flask to turn this project into a real server program. Okay, so what I need to do here is first of all, I need to import Flask. Oh, they started writing for you. Okay, but that's fine. I think this is exactly what I need to do. So we import Flask, and then we create a little app, which is the object, and then you just create this Flask. I'm gonna just right this way so I don't have to wait. Flask import. I think it's this one. All right. So we import a Flask class and then we create object. Okay, so that's just a very basic stuff. You just have to write this anyway. So I'm gonna run this to make sure everything is work. Okay, so it looks fine. Now how do I turn this into a Python server? Okay, so remember, the most important part is right here. This is a function. That's the core logic we have. Okay, what I want to do is I want to somehow expose this one to the internet so others can use internet to interact and call this function without having the program. That's the goal. Now think about in the browser, every time you want to interact something, you normally use a URL to do it. That's how you provide a server name, address, all the different slash for different functions. Okay, so when you are building your server program, you must think about what are the URLs you want to have. So what you want to do here is I'm going to write something. I put an annotation. I do app.route, and then inside this code, I'm going to do a little URL here. So I'm going to say that this is going to be search. Okay, search. I'll just do a search. All right. And then because this function takes a input, we need an input price. Okay, so what I need to add here is I need to add a little bit more. I put a price also into URL. So I do slash search and then slash the price. The price I put, and after the last slash will be the input number, so that I can have a way to pass that inputs to the URL. And then this pricing is going to get it. But here I need to do one more thing because that price is not a integer because coming from a URL, it's like a string. So I need to turn that into a float or integer to do a quick conversion. That's how the program will work. Okay. So with that, we're done with our server program. So far, I did one line to import, one line to create a web application, and another line to just indicate that URL to tell people that if you ever visit my server with this URL format, I'm going to direct you to this function. I will call and run this function for you. Okay. After that, you're going to see the result returned. Okay. So let's see how it works. Now I'm going to comment on this one and I will run this code. Right now, nothing happened because I didn't start my server yet. So I need to do app.run. And then I'll add one parameter here called host. Okay. Host, I provide IP address. So this host indicates all the IPs you are going to allow to visit the server just for security purposes. If you build a server, you don't want all the different IPs to visit yours, you can, make it more restricted. But in this case, I just want the whole world to be able to open it, to visit it. So I do 0000, which means anywhere. That's a special IP address. Okay. So now let's try to run this again. Oh, it's hard to use because I'm probably already run something here. Let me see. Let me see. How do I get the other one? Okay. Oh, okay. So there wasn't any port using. We try a different port. All right. Anyway, so just change a different port. Okay. Somehow the 5,000 was using. All right. So now this time, okay, you can see the terminal here. I run the Python server. I use this line. And one thing you should notice is that this code right now is still running. You see, terminal is stuck here. It's not like you run it, then you finish. That's called always on, always running. In the backend, they already have some kind of a thread pool creating, and they're listening. Okay, and they also tell you we're running on all the addresses, and that you can access server with this address. Okay, 127. That's a local host. Okay, so if I go to that URL, and then they're gonna see they open the browser. And right now they didn't find anything because we haven't specified what is the URL we're trying to visit. Okay, so we only know the host. All right, so and now I go to the slash, I do search, and I do search for $10. Okay, remember that's a URL we define here in the program with this format. So if I do that one, I hit enter. Now here's the results. Okay. So you see the same kind of format as we just print the list of dictionaries, but the difference is now everything comes from browser. The browser has nothing to do with the Python. All you're doing is just go to the URL, bid the server, and the server sends this response to you, and you can see the result directly on the browser. And then if you change this one into $5, and you see less results. Okay, now right now this is just my local server. In the future, we'll talk about how do we deploy the server into cloud so that every one of you can also visit this one. But then now the server is showing up, right? So you interact with the server program through internet, specifically through HTTP request. Okay, so that is called a server program. As you can see, every time we visit something, you can find a log people are visiting this one. Following the same approach, you can do a lot of other things. For example, I can say just show hello world. Okay, this one I don't do anything, just return. I'll return welcome to CS4800. Okay, this is the function. Okay, if you want to expose this function to the internet, use app.route and then give a URL. Say hello. That's the URL you specify. And then we can do is rerun this code. Run this again. All right, so this one still works. Now we add a new URL. So I go to here /hello, and you see this one. All right. If you start changing the content here, all right, and then stop this, run this again, refresh, and then you're gonna see different kind of content. Okay, so this kind of maximum is called a request mapping. So what you're trying to map is that you're trying to map the URL to a Python program or Python function. Most of this language or web framework does this way. In Java, you see the similar structure, Node.js, all the same way. So you often have a lot of functions to call. And on the top of the function, you specify what kind of URLs to use to trigger that function. Because once you turn that into URL, then you can see, all the they can visit this one from the browser. Okay, so I did spend a lot of time to tell you that Python, the server program is very complicated, but using framework, it's such a fun way to code. Okay, one line of code here to import, one line to create an object, one line to specify the mapping, and one line to run the server. So really 4 lines of code, you turn a regular Python program into a server program. It's really easy. But don't forget, the moment you import this stuff, you are actually bringing a lot of code to your code base that probably many people have wrote for many years before. Okay, so that's the power of web frameworks. All right, but with this, yeah, we are back in that. Okay, so we just don't have a very clean and pretty UI, but the search function is here. You just need to search and then you got the function you want. Okay, and next, all we need to do is build a nicer front end to make it look better. All right. Any questions so far? All right. So with that, okay, let's speed up a little bit. We have this part all done. Okay. The next time we improve the database to make it more professional. Front end, we use HTML. Okay. To write HTML, and then we can try to put this one all in the same folder. Okay. So I'll put index.html. All right. This one, most of you probably done this more or less. We just write something very simple. Okay. Got a body here, got a welcome. Let's make sure that we can still run this one. Okay. Yeah, that's the URL here. And but let me change this one to budget lunch. Okay, save. All right. And then we need some input boxes here. Remember the design. This is our design. Okay. An input box, a button, and then list. Okay. So this one will be the input. Yeah, so they pretty much figure out everything for us, but that's great. And then they have a button here. And yeah, I'm gonna take those. I don't know where they get all the code, but it looks a little scary. But anyway, so here is the input and here's the button. So let's ignore the script here first, okay? Because this is too much. And then here they use the division just to store all the results. Okay, so later on you can put other things inside. Yeah, you can use this kind of unordered items, like something like this. All right, so that's a front end. Okay, see, input is a box, button is a button, and the division is a group, and then this is called an unordered list, a list of items, and then you got all these items. That's what you see here. Very simple HTML. Okay. And then, but this is static, nothing to do with your servers. You type anything here, it doesn't do anything because they're not connected. So that's why I'm showing you here. You build front-end pages. How do you allow this kind of communication? Okay, previously we were in the browser sending the URL. Here you do the same thing, but you have to go through the different way using JavaScript. You had to use the code to do it. So the moment you click on the button, we send that some request to the server, get the result back, and render them. Okay, so now we just need to put them together. Okay, we need to put them together. So that part actually I forgot how to do it, but let me see if the cursor is back because right before the class the cursor was down. Okay, add the index.html to the Flask server so that the server starts with the index as the home page. Okay, it's back. So let's see. So they just need to do some kind of a dependency, change it here and add the file. There may be some folder stuff. I can't remember how to do it, but they're gonna do it for you. See, if you never seen how the cursor works. The difference between this and ChatGPT is that they directly works with your code. Okay, you could obviously copy the code to ChatGPT, get answer, and then you copy the code back, but it won't handle multiple files. It won't know what's going on here. Here, they just change directly on top of your file. They also want you to track the changes so that you know what's being done, and then you take it or not. That's why this is for the AI coding, you just have to use some of the tools like this. Okay, so they add a new dependency called a render template and send from directory. That's the thing that I can't remember. In the past, normally in the class, I just go to Google to search, right? So now everything being changed. Okay, we don't really Google those anymore. And then you just add one more route here for home. See, this one, if you do slash, it's going to send the HTML file. Very simple logic. Yeah, I just can't remember how to do this. So nothing really crazy being generated. I'm going to keep all of them. And then I'll try to rerun this. Okay. So now if we go our home, oh wait, they even did they did a when did they do that? Oh come on, they did a CSS for us also, okay. But oh they probably also did everything. Okay. But anyway, so that's the HTML file, and then you input your budget and you search. I don't know if that search works, but I tried that. Yeah, even that works. Okay, but that's fine. I want to go back to review this a little bit. So first of all, I add that index file to the same folder. So this server, we put a specific URL to handle that home page. See, this one, it doesn't do anything. It returns HTML file back to you. That's why you can see this. Okay. But what's being done here more is we shouldn't let them to do is how do you interact with the page. So they made two changes. This was the one we had before. Okay, some heading, some search, some input, and some buttons. First of all, they add a lot of CSS. As you can see, this part of the code is the CSS style configuration that controls all the color, all this different stuff, right? So if you want a different color, I guess, some of those, there's a blue one. Is this for the button? Oh yeah, this is for the button. Okay. So if you want to change that one into a different one, okay, save it, and then that's how you can change it. Okay. The the all the UIs, the layout are specified here, something called a CSS. Okay, most of you probably already know this. All right. So, but they have more detailed stuff for layout, for everything. Now, the most important part for this code is the button. Okay. So I input something, I click on search, and that moment is going to trigger a request to our server. The server get it and then return the results back. So that whole process happens in the background because previously I showed you you go to localhost, right? And then you do search, you do 10. So this one still works, but that's how you interact with the server manually through the browser. But now everything is under the code. You can't do that way. You need to use the code to do that kind of request. So that's where you need a JavaScript. So JavaScript is a language that runs in the browser. It does all the dynamic stuff, all the things in the background. So JavaScript is so important. Without JavaScript, none of your web application is going to work. It's only static. You just put some pictures, images, text. JavaScript allows you to do anything you want inside the browser. Most stuff have happened in the background. Okay, so the JavaScript code actually shows up right here. So they have just one function here, actually two. The first one is called they add a listener. So whenever you click on the button, they're gonna run this function here and they grab the budget that you need. And then the most important thing is here, guys. You see it fetch slash search slash budget. So you can pretty much tell the meaning that they grab the budget you input and form a URL, and they use the JavaScript to call that URL and then get a response. Once they get a response, they will display the results into the web pages. Okay. Honestly, this part I also need to search a little bit to write. So that's why, probably having AI to write it is easier. Okay. However, if you don't even know what's going on, what you want to do, just giving the cursor to like this is probably not going to work very well, especially once this one goes a little bit more complicated. Okay. So I want them to do one more thing. Please create separate files to store CSS and JavaScript from the index.html. So that way we can see that clearly. They actually put everything together. So normally what you do, you create a dedicated file for the styles, and then you create another file for JavaScript. So you save them separately. Okay, so that's a better practice. Okay, so they move all of this one just to the single file called a CSS file. Okay, so they're gone from here. And then here, all you need to do is to import it. Eventually, I think they're going to change it. And then they also create a JavaScript file here. And then finally, they modify uh, index. So I'm going to take all the changes. All right, so now the thing's probably getting a little bit clearer. Okay, so this is HTML, okay? Just having all the tags to specify the component, the button, and everything. Once again, this is a logo. That's the input box. That's the search button. And then here is a place where you store the results. Okay, that only specify just the layout, but no style. The styles are here. All the color, the font type, everything is specified here. You can always change it. And finally, the JavaScript is the one that put everything together between the front end and the back end. So the JavaScript, you click on the button, um, oh, here. So you click on the button, you grab the budget, and then you send the URL, wait for the results, and if the result comes, we're gonna show the results. Okay, that's how everything works together. Okay, so if we run, oh wait, somehow it's not working. So they're not, I might need to rerun this. Okay. Yeah, something's wrong. They're not doing the CSS styles very correctly, actually. The function might still work. No, this is all stopped working. So did they? The CSS file and JavaScript file are not linked correctly. Yeah, let's see if something wrong, but I don't think anything special here. Yeah, maybe they gotta change this code here. Yeah, that's what I saw. Yeah, you probably have to import that code somehow. Okay. All right, try this again. All right, so that's all the files loaded, and then you can do the search, and that's all the results. 6. All right. So a very quick demonstration. I did skip a little bit too much on the JavaScript part, but that part is also very hard for me to write from scratch. I also got to Google back and forth. Okay. But then the purpose of this demo is to let you know that building a web service like this, okay, uh, definitely has a lot of work. But then first of all, you got to understand the architecture behind it. Okay. From the bottom database part to the server part, and then build your front end, and then connect front end back end together. Okay. So hopefully with this, when you guys start to discuss the options, you guys want to use Node.js, React.js, Next.js, all of this, that's fine. You can start to map to the concept back to this example. In the beginning, it's a lot of work, a lot of learning. Okay, pretty hard to do. I done this kind of demo many times, so I don't have any issues. Okay, but in the first time you do this, you have a lot of problems. That's fine. Use all the tools AI to help you. But this type of project is a lot of fun. Okay, because these are real practical stuff. Any kind of software you build today, if they are not like connected to the internet, it's pretty much useless. Okay, so that's why after you graduate, you start to find jobs. Most of the time, you start work with as a backend engineer. Front-end normally require a lot of experiences. If you never done front-end design those before, you can't do that very well. But for the backend, as long as you know Java, Python, then you can start work on it. Okay, so normally you start from the backend, but when you work on the backend, you should know that you're not just writing a regular Java code, you're writing that under a framework. Okay, so all these are very practical things. So definitely pick it up. As I mentioned, the team members, you can split your role between front end and back end database, but I think today you see the title called a full stack. So when you see full stack, that means the developer can handle all of this together. Yeah, that's kind of expectation from today. Because normally you work on a team and they will give you a feature. For example, they're gonna say, okay, could you add a feature to be able to manage the food from a portal? So that kind of feature changes requires everything. Okay, you gotta have the database to show those. You're gonna have this server to be able to change those, and then the front end you also need to change some UI. So most of the developers will do everything together. So that's called a full stack development. Okay, so that's pretty much the trend today, and yeah, use this opportunity, try to pick up something new. All right. Yeah, so next time I'll show you some kind of uh using maybe MongoDB, other database to do it because this database here is very naive. So so that you can see the final picture of the project. All right, so that's all for today. Any questions? All right, then I will see you on Thursday. Okay, still in person.